So the next question is asking us to get, so they have said find the acute angle, so the acute angle between lines. So we have been given here two linear equations or two straight lines, and the first one is y plus 2x is equal to 5. Okay, and the other one is 2y minus 6x, and then that is plus 8. Yes, so plus 8, as it must be equal to 0. So they want us to get the acute angle between these two linear equations. And of course, these are equations of straight lines in mathematics, and of course, they are not in the form y is equals to mx plus c. And what you need to know is that an acute angle is an angle that is actually able to range between 0 and 90 degrees. So for the case of this acute angle, then I'm supposed to get an answer that ranges between 0 degrees less than or equal to that acute angle, which can be theta, less than or equal to 90 degrees. So any value of what I'm going to get as my acute angle should be between this range. So the theta that I'm going to get should be between 0 and 90. That now makes it to qualify to become an acute angle. So how do I get the angle formed between these two lines? So of course, I can expect these lines to be like this. And of course, I will have this. So maybe this and this. So maybe this is the first line in that case, and this is the second line. They're going to form an acute angle between them. So the theta that we're actually going to get here should be an acute angle between 0 and 90. So this is our first linear equation. This is our first straight line. This is our first linear line. This is our second linear equation. When they meet, they're going to form an angle, which is theta. It must be an acute angle. So what I need first to do is to ensure that those lines are written in the form y is equal to mx plus c, so that I can be able to get the slope or the gradient. So first I'll have y plus 2x is equal to 5. So for you to get the gradient, or for you to get an angle formed between two lines that meet or intersect, you're supposed to first to ensure that the equations of those two lines are written in the form y is equals to mx plus c. So that from those forms in which those equations have been written, you can be able to have what you call the slope or the gradient. Then use those gradients or the slopes to have the angle formed between those two lines when they intersect. So I'll first come and say that these are the two lines. This can be the first line and this can be the second line. They are intersecting at this point. Let me say this is point A. At the point of intersection, they end up forming an angle theta. And this angle I've actually been told is an acute angle. It must be between 0 and 90 degrees. Of course, an angle found within a triangle, for that case, if I actually end up completing this diagram, so that I can form a triangle. So it must always be less than 90 and more than 0 for that matter. So we will say first, let these equations be written in the form y is equals to mx plus c. So I've actually begun with the first equation. I'll go to the second one later. So I'll come here and say, let me take this on this other side. It will be now y is equals to negative 2x plus 5. If it is positive, on crossing the equal sign, it becomes minus 2x. So it will be minus 2x plus 5. Okay. So that my gradient or slope, my student, is negative 2. Wow. So let me go to the second one. So I'll have 2y minus 6x plus 8 is equals to 0. I'll take these two on this other side of the equal sign. So then I'll be able to have now, so of course, I'll actually tell you that the gradient is always the coefficient of x in that form of y is equals to mx plus c. So m becomes the gradient. M, the coefficient of x becomes the gradient. So coefficient of x is negative 2. So our gradient is negative 2. Look at that. So let's proceed. I'll now come to the second equation. I'll take all these two on this other side of the equal sign. I'll be able to have 2y is equals to 6x minus 8. Negative 6x becomes positive 6x. Positive 8 becomes negative 8. You can see I've just transferred all of them at once on this other side. So I'll divide all through by 2. Because in the form y is equal to mx plus c, the coefficient of y must be 1. We do not need to have any numeral here apart from 1. So this and this will disappear. So I'll be able to likely end up having y is equals to 3x minus 4. So my m, or my gradient, is equals to 3. So I can have this as my m1, my first gradient, for the sake of making a difference between those two, and then this can be m2. So and then the value of theta, I can use what you call tan theta. So the right trigonometric function to use in getting a particular angle that the line forms with another line, or the line forms with the x-axis, is always using tan. So tan theta is equals to, I'll have m1 minus m2. This is the formula of getting now the value of theta. So I'll just say tan theta is equals to m1 minus m2, and then we divide this by 1 plus m1 multiplied by m2. This is a very common formula that mathematicians use to get a particular angle formed between two lines. Wow. Okay, so but if this is a Cartesian plane and there's a line that forms a particular angle with the x-axis, so here we only have this as our line to consider. And if maybe that line is y is equals to, I can have maybe 3x plus 2, no problem. That is the case. So if this is my line and they're asking for the theta that this line makes with the x-axis, or y is equals to 0, what do I need to do? I just get the tan inverse of this. I'll be good to go. The tan inverse of the gradient of that line that makes that angle with the x-axis will be now the theta. But here, if two lines are intersecting and not making any contact or intersection with the x-axis, I need to get their respective gradients, then use this formula. So our m1 is -2, our m2 is 3. We divide by 1 plus m1 -2, then m2 is 3. Wow. So we are just getting the answer right away. So I'll be able to end up having -2, -3 will give us -5 over 1 plus, so it will be 1 plus -6, because it will be 1 plus, so -2 times 3 is -6. So this will give us -5 over -5, which gives us 1. So then I know very well that tan theta is equals to 1. So I need to get the tan inverse, and the inverse of tan is arctan. So arctan of 1. Very good. So just press shift and then tan to be able to give you the value. So shift, then tan of 1. So it is 45 degrees. So the value of theta in this case is 45 degrees. And you're good to go. That becomes your final answer for that question.